Hey, what's up? It's your old pal, Mr. Cook, and we are continuing on the group work first page. We're going to do numbers 5, 6, 7, and also 8 on this one. And, maybe we can start up with the word problems if we have enough time. So, first off, this is an arithmetic sequence, and I'm given two terms. We practice these a ton in our worksheets, and there is a method to solve it. It actually stems from the fact that arithmetic sequences are like linear equations. And so if we're given two terms, it's the equivalent of having two coordinates in a linear equation. If we have two coordinates, we can find the slope and come up with a formula for it. Same thing goes on with the arithmetic sequence. Basically, like, what you need to realize is that these two terms that you have are like coordinates. When you plug in 3 for n, you get into some sequence, some arithmetic sequence, then you get -2 for the term itself. So you can think of it as a coordinate. It's like if we plug in n to the explicit rule, we get out an. So if we plug in 3, we get out -2. If we plug in 6, we get out -11. And since arithmetic sequences are more or less linear relationships, we can find the common difference by using the slope formula. This term right here, -11, the difference between this and -2, over the difference between the term numbers 6 and 3, we'll find our common difference. So y2 minus y1 over x2 minus x1. So -11 plus 2 is -9. 6 minus 3 is 3, and -9 over 3 is -3. We just found our common difference. So now, once we have the common difference, we can write out the explicit rule using the formula that we have over here. So let me rewrite that. an is equal to a1 plus the common difference, d, times n minus 1. Now, we just found the common difference, so I'm going to plug that part in, -3. So this just becomes a -3, and then times n minus 1. And then we need to figure out the first term. That completes the sequence. Well, this is really close to remember the problems that you guys had in algebra where it was like slope-intercept form, and then you were given two coordinates, like 1, 3, and -8, 15 or something. And you found the slope, and then you plugged in one of the coordinates for x and y to solve for b. This is going to be very similar to that, because what we're going to do is we have this partial part of we have this formula almost done, but we need to find the a1 value. So what we're going to do is use one of our little coordinates that we created with n and an, and then plug it in to solve for a1. So let's use this little coordinate that we started with, because it's smaller numbers, and those are easier to manage. So -2 goes in for an, so -2 is equal to a1, which we don't know, minus 3 times our n value, which is 3 for this coordinate, minus 1. So now the only unknown value is a1, and we can solve for that and complete our equation and also answer part b as we go. So we get -2 is equal to a1, and then 3 minus 1 is 2. 2 times -3 is -6. So we add 6 to both sides, and we get 4 is equal to a1. So that gives us our answer over here, a1 equals 4. And it also gives us the last piece that we needed for our equation. a1 is equal to 4. So we're just going to plug that in there. And just like that, we have our explicit rule. Explicit rules are really, really helpful if you need to find a specific term in a sequence. If we needed to find, say, the 68th term, we'd plug in 68 for n. If we needed to find the 12th term, we'd plug in 12 for n. And in this case, if we need to find the 100th term, we just simply plug in 100 for n. And we get our answer. All right, let's use our calculator for that one. So 4 minus 3 times 100 minus 1 is 99. And we get our answer, -293. Easy enough. All right, now let's move on to the next problem. So now, same scenario, same startup. We have two terms. The difference is now it's a geometric sequence. So the way that you were taught to get the geometric sequence from two terms in class was you basically build a proportion out of this. Now, I'm going to cut some corners here, and you just got to trust me that this is going to work every single time. But since it's a geometric sequence, and the geometric sequence is just multiplied by a common ratio each time, we can find that common ratio from these terms. It's basically the same idea with the coordinates that we had in the previous one. It's just a little bit different, okay? So with the arithmetic sequence, we think of it as a slope and use the slope formula to solve. With the geometric sequence, we think of it as a proportion, and so we use a ratio, so we use a proportion to solve. So to get r by itself, here's what we do. We recognize that by the fifth term, we're going to multiply that geometric sequence's common ratio 5 times on there. So it'd be r to the 5th power at that point. You know, I know that we're going to have to multiply by some other term, the first term, to get to this number 64, but let's just assume that we don't have to worry about that from now, because you actually don't. It cancels out. Now, let's also look at a2 is equal to 8. By this time, we will have used our common ratio twice. So let's write r squared is equal to 8. So now that we have these two equivalent values, let's create a proportion. So the proportion goes like this. If you take the larger of the r values, so r to the 5th, and you put it over the smaller r value, r to the 2nd, and then set it equal to its equivalent numbers in a fraction, you can start solving this. So it's really easy to solve. R to the 5th over r to the 2nd power is r to the 3rd, and then 64 over 8 is 8, and then if you just simply take the cube root of both sides, you get your common ratio. Cube root of 8 is equal to 2, so common ratio equals 2. And similar to the previous problem, you know, we can use our explicit rule, an is equal to a1 times r to the power of n minus 1, and start plugging in some of the stuff that we have. We already have 2 for our common ratio, and we need to solve for the a1 value again. So similarly, we go back to our little coordinates. Like if we plug in 2 for n, we'll get out 8 for our an value. So I'm going to use that over here and plug in 8 for an. And then 2 for my n value, so 2 minus 1. Okay, so now this is just the only unknown value is a1, so I can solve for it. 8 is equal to a1 times, let's see, 2 to the first, which is just 2, and then divide by 2, and you get your answer for a1, which is just simply 4. Okay, so here's my explicit rule. Just replace the a1 with 4 over there. Explicit rule. And we also solve for a1, so let's put the answer up here as well. a1 equals 4. Okay, now that we have an explicit rule, we can find any term that we want, any individual term. If we wanted to find the 20th term, we plug in 20, and so on. So if we're looking for the 8th term, just plug in 8. So a8 is equal to 4 times parentheses 2 to the power of 8 minus 1. 8 minus 1 is 7. 4 times 2 to the 7th is 512. So 512 is our answer. Okay. Next, find the sum of the first. Okay, let's stop. The sum, okay, I know sum formulas. This is a summation formula because it says Sn. This is a summation formula because it says Sn. And this is also a summation formula for infinitely many terms. Luckily, this one says we just have 40 terms. So we're probably going to use either this one or this one. We're not going to make you guys add up 40 terms by hand. So it's probably going to be in arithmetic sequence or geometric. Let's figure it out. So the sequence goes from 1 to 5 to 9 to 13 to 17, so it keeps adding by 4 each time. If it keeps adding by the same number each and every time, it's arithmetic. And that means that we can solve for an explicit formula to solve, to get any individual term that we want. So the explicit rule goes like this. an is equal to a1 plus d times n minus 1. D is our common difference, so it's 4. A1 is our very first term, which is 1. There's our equation. Okay, but that's the equation that we can use. We don't need it because we're going to be using the summation formula. The summation formula up here for arithmetic sequences, so Sn is equal to n over 2 times a1 plus an. So what do these things mean? Well, n is the number of terms that we're adding together, so it said 40. So that means that n is equal to 40, so 40 over 2. A1 is the very first term in our sequence. We already know what that is, 1. And then an is going to be the very last term in our sequence, so the 40th term. So I guess I can keep adding 4 until I get to 40 terms. Or I could just use this explicit rule that I solved for and just plug in 40. So that's what I'm going to do. The 40th term, a40, is equal to 1 plus 4 times 40 minus 1. I don't know why I just completed that parenthesis there, 40 minus 1, there we go. So then just, use your calculator for that one. So 1 plus 4 times parentheses 40 minus 1, so 39, let's just write 39 in there. And we get 157. So 157 goes in here for our last term. And then we just simply evaluate it. So this is 20 times 158. And I don't remember what that is. I think it was like 3,160 or something. Let's see, 20 times 158. Yeah. 3,160. So there's our summation. All right, one more problem and then we'll stop this video and start up another one that's fresh with word problems. So that'll be pretty nice. All right, factorials. Factorials are when you keep multiplying by the like the next lowest whole number until you get to 1. Or I guess natural number, yeah. So next lowest natural number until you get to 1. So like 15 factorial is 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So I stop there. 8 factorial is 8 times 7 times, wait a minute, I already did that up here, didn't I? So, okay, 8 factorial is just this stuff, so I'm just going to cancel out this and my 8 factorial. There you go. And then 4 factorial is 4 times 3 times 2 times 1. I don't have any of those up top anymore. So these are all gone. And I'm just left with these numbers now. So let's try and reduce this. Well, I know that 4 times 3 is 12, so I can cancel out these two 12s. And then 14 and 10 are both divisible by 2, so I'll divide out a 2 from the 10, I guess. So I'll cancel those out. That just becomes a 5. Now I'm just, to find this, I just simply need to multiply 15 times 14 times 13 times 11 times 5 times 9 on my calculator. And I've already done this, a couple times in class, so I know that it's going to be 135, 135, 0 when you multiply them all together. So there's our little answer for that. The analytical ones are a little bit, I think challenging for some if you're not very good with the analytical side of mathematics. But, it's not that bad. You just got to follow the rules for your factorial. So, it always starts with the same number, whatever you're raising to the factorial, then just do that number, so n plus 2. And then we multiply that by the next lowest natural number, so we'd subtract 1 from it. Now let's see what that would be, n plus 2 minus 1. So 2 minus 1 is 1, so it's n plus 1 instead, so n plus 1. Next, we go to the next lowest natural number, so we subtract 1 from that, so n plus 1 minus 1. And that's just going to be n because the 1's cancel out. Then we go to the next lowest natural number, so n minus 1. So just n minus 1, that's all we can do with it. And the next lowest natural number, n minus 1, which is n minus 2. And so on. And then it goes n minus 3, n minus 4, all the way down until it gets to 1 eventually at some point. Now n minus 1 factorial just starts at n minus 1, and then we go to the next lowest number, which should seem familiar. It's n minus 2, n minus 3, and all that stuff. So since we're, dividing, we can just cancel all this out. Then our answer is just going to be n plus 2 times n plus 1 times n, and that's our answer. You can, distribute it out if you want, but I don't really see any point in that. You can just leave it like that, and that's good to go. Okay, so that's it for these last couple of problems. If you want more practice from this, go to the worksheets in your packet. You can do more of those. There's plenty of practice to work on. We're going to work on the word problems next, and that'll be it.